All right, guys, welcome to 096. We are now going to move into our Unit 4 notes, which is the start of graphing linear equations. We are going to start off by talking about different types of linear equations that we have. That way you have an idea that keeps coming back in your minds as to, okay, I know what a linear equation looks like, and now because we discussed the type and the name, you can associate those two things together. You can associate the form with its actual name. That's going to be very important. Then we're going to move into figuring out how to plot points. And then we're going to graph lines by plotting points. And I think that's all we're going to end up covering in today's class, but we'll see how it goes. At any point, if you have any questions, don't hesitate to ask. I can see the chat, so let's do this. All right, Unit 4 notes. So let's do a quick recap. How do we know an equation is linear? We know that an equation is linear when there is no term with a variable being raised to a power higher than 1. We talked about this when we were looking at Unit 2 notes. We talked about the fact that when we have a variable raised to a power of 2 or 3 or 4 or anything higher, it becomes non-linear. But when the highest power of your variable is 1, then you know it is linear, a line. So there are 5 different examples here of the types of linear equations that we're going to see in this unit. And what I wanted to do was take a moment to give you the names of each type. And I urge you to be super familiar with these types. I want you to know them through and through. So our first type of linear equation is something that looks like this, where we have 2x minus 3y equals 5, where all of your variables are on one side and your constant is on the other side. This particular linear equation is in standard form. Notice here that A, B, and C all represent real numbers, but X and Y are the variables that will remain in standard form. So your variables are on one side, your constant is on the other. That is standard form. When we have Y isolated on its own, then we have Y is equal to mx plus b, or 1/5 x minus 3. This is called slope-intercept form. Okay. Y equals 1/5 x minus 3 represents slope-intercept form. For our third type, notice the format here follows y minus y1 is equal to m times x minus x1. Notice that this example has parentheses, just like the general form has parentheses. So we call this point slope form. Point slope form will always have parentheses, point slope parentheses, P, point slope parentheses. Okay, remember that. If you were to write point slope and it doesn't have that set of parentheses in there, then you didn't write it correctly. It must have that set of parentheses. We have a type of equation where x is equal to any number. If x is equal to any number, this is actually a vertical line. And remember, vertical implies up and down. Okay. Whereas y is equal to -1, this will represent a horizontal line. And I'll explain why that is. And hopefully in that explanation, you'll be able to say, oh yeah, that makes sense. There is no other way that this would look. So x is equal to 3 is definitely going to be vertical. Y is equal to a number has to be horizontal. And you'll see when we actually talk about this, when we get there. Next, Next, we have something called the Cartesian coordinate system or the rectangular coordinate system. The first thing I'd like to do is I'd like to identify the quadrants for you. What I'd like you to picture is a clock superimposed over this graph. So if you're picturing a clock and the hands of a clock and all the numbers on a clock, would you agree that the 1 would be here in the upper right-hand side? So if the 1 would be here, this is quadrant 1. All of the points in this region are in quadrant 1. Next, when we think about the 4 o'clock on a clock, I know I keep repeating myself, the 4 would be in the bottom right-hand corner. So here is quadrant 4. And if we follow this counterclockwise, this is 1, this is quadrant 2, this is quadrant 3, and there's quadrant 4. Okay? No worries, Haley. Awesome. I'm glad you joined us. Anytime we plot points on a rectangular coordinate system, we always plot the points in ordered pair form. So for instance, our ordered pair will always be x then y. Hopefully that should make sense. I mean, think about order in terms of alphabetical order. Let's say we had a z coordinate as well. Then it would be x, y, z. So we want to make sure that every time we plot points, it's always the x coordinate first and then the y coordinate second. So it has to be x, then y. Notice I put a note here that said you move left or right in the x direction and then you move up or down in the y direction. So x is left to right, y is up and down. Whenever you plot points, you always start in the center of the graph. And sure, I don't mind reading the definition again at the top. So as a quick note here, notice that we know an equation is linear if there's no term with a variable being raised to a power higher than 1. Okay? Or in other words, the highest power of any variable in the equation is a 1. Okay? And these are examples of those linear equations. If you had a term with multiple variables, those powers combine, so it's nonlinear. So we're just saying, we're speaking strictly if each term has one variable, the highest power of each variable is 1. That's what makes it linear. Okay, just to make sure that we're all on the same page, I would like to plot the point -5, 3, and let's call this point A. You're welcome, Anthony. We're going to call this point A. I want you to consider that my x coordinate is -5 and my y coordinate is 3. So what this -5 implies is we're going to move left 5 units, 1, 2, 3, 4, 5, and then the y is a +3, so we're going to go up 3 units, 1, 2, 3. After you move the full direction, then we label that point A. Does that make sense? Okay, so always move in x direction, then move y. So x, then y. Let's turn the page and try to plot a bunch of points. Okay, so we're going to practice plotting points here. So on the graph below, we're going to plot the following ordered pairs, which are here. And we're going to label the points just like we did before, and then we're going to indicate which quadrant that point belongs to. So again, I'm going to show you this first one. So A, the point A, has coordinates 4, 5. So we're going to go 4 on x, so 1, 2, 3, 4, and then 5 on y, 1, 2, 3, 4, 5. Notice that it gives you a directive. Hi, Brian. It gives you a directive. So +4 means right 4 on x, +5 means up 5. And we found point A. Notice that point A fell squarely inside of quadrant 1. So our point B is in -2, 1. So if we were going to identify -2, 1, that means we're going to go left 2 units, 1, 2, up 1. There's point B, and that is in quadrant 2. Next, we have C, which is 0.30. Notice X is a positive 3, so 1, 2, 3, but Y is 0, so we stay right here. Now, because it doesn't fall in any specific quadrant, we wouldn't specify it's in a quadrant. We would simply say this is on the x-axis. I know, tricky. So the point D is 5, -7. So we're going to go over 1, 2, 3, 4, 5, and down 7. 1, 2, 3, 4, 5, 6, 7. Okay, here's my point D. That is in quadrant 4. Next, we're going to look at point E, which is -6 and -2. So we're going to go left 6 units, 1, 2, 3, 4, 5, 6, and down 2. There's point E. This happens to be in quadrant 3. Next, we have point F, which is 0, -1. So 0 in the center, that's X, right? We don't move left or right because it's 0. And it says -1, so we move down 1. And that's on the Y-axis. This next piece might have given you a little bit of issues, but I don't want you to overthink this. Consider it simply says move left 6.5 and then down 4.5 because X is left or right and then Y is up or down. So we're going to move left 6.5 units. So 1, 2, 3, 4, 5, 6.5. And then we're going to go down 4.5 units. 1, 2, 3, 4.5. So when you plot your point for G, it should be right smack in the center of that grid, just like so. Okay, we are in quadrant 3 with point G. For point H, we have 9/2 and 3/2. Think of this as a fraction is a division problem, right? So 9/2 is 9 divided by 2. And 9 divided by 2 is 4.5. 3 divided by 2 is 1.5. So now we're going to plot H. 4.5 and then 1.5. So 4.5 is 1, 2, 3, 4.5. And then up 1.5 means we're going to be right here within the grid marks. Okay, and this is point H. And lastly, oh, by the way, that's quadrant 1. And lastly, we have point I, which is 0, 0. That's right smack in the center of our grid. And that is the origin. Okay, excellent. Hopefully that went well for you guys in terms of plotting those points. Again, if you have any questions as we're moving through, please don't hesitate to ask in the live chat. Okay, but for now, we're going to continue by learning how to graph by plotting points. Okay, so if we're graphing by plotting points, what I wanted to do was I wanted to show you the rules. And then I wanted to, at the same time as going through the rules with you, I want to show you what it looks like. So we're going to do one step at a time. Okay, graphing by plotting points. Rule number 1. We're going to rewrite the equation in slope-intercept form. Recall that slope-intercept form is when you isolate y. So y has to be by itself, and it's equal to mx plus b. What this implies is that your terms are going to be in descending order, and I'll explain what that means again in a second. So we want to focus on getting y alone. Back in Unit 2, we talked about isolating an indicated variable, and we learned that if we wanted to move terms, we can only add or subtract them. If we want to get y isolated on one side of the equation, that means we want the 3x to go away. Okay, notice it's a positive 3x, so we are going to subtract 3x to bring it over. That's my first step. I have to either add or subtract terms to move them from one side to the other. I'm going to bring down my -4y. Notice the 3x's will end up canceling each other, so I don't even bring down a 0. I simply just cancel them out. And then we have -12 minus 3x. Now recall that I said I want to write this in descending order. So I'm going to write the -3x first, then the -12 second. Consider I want this to match that y equals mx plus b format. So we're almost there. Y is not quite on its own. Notice that -4 is attached to y by multiplication. So if we wanted to get y by itself, we're going to have to do the opposite, which is to divide by the -4. Recall that when you multiply or divide in any equation, you've got to do that to every single term. You do not get to pick and choose. It's not how math works. So when we simplify each term, that gives us y is equal to, notice a negative divided by a negative is a positive, so we get positive 3 over 4x. Notice a negative divided by a negative is a positive, and 12 divided by 4 is 3. So I officially got y by itself. So that takes care of step number 1. So I'm going to put a little 1 next to here because that correlates with step number 1, or corresponds to step number 1. Okay, step 2. Strategically, this is very, very important. Sometimes we forget about that strategy behind our decisions when we decide to graph by plotting points. So I'm going to talk to you about the strategy behind choosing any two values for x. So first off, one of the numbers I always like to plug in for x, because it tends to make life a little bit easier, is I allow x to be 0. Now I want to just talk to you for a moment. I want you to think of any line. I want you to visualize that in your mind. And I want you to imagine that this line is going to continue in either direction to infinity, correct? It's just going to continue to go in either direction. The reason I want you to visualize this line is because I want you to also consider the number of points on any particular line. So for instance, if I gave you a point and I said plot that point, you'd put it somewhere in space. But then if I say take another point and plot that, the second you put your next point, you can now connect that with a line, right? So if you place a point here in space, you place another point here in space, and then you connect it, bam, you have a line. But I want you to consider that while having 2 points will allow you to draw a line, that specific line has an infinite number of points. Right, wouldn't it? You can literally take a line and plot all the points that are on that line. You can attempt to, right? You can have software that does that. You can attempt to plot all the points that belong on that line. So because there's an infinite number of points on any one line, we actually have the power to choose an input, to choose our x value, and then we have to do the math to calculate its corresponding y. So think of it as like an input, output, right? You have an equation. In this case, it's y is equal to 3/4 x plus 3. So you have an equation. Your x is going to represent the input, the independent variable. So x is our input. If we choose a value, whatever we want, because we know there's an infinite number of points, if we choose a value for x and plug that into the equation, then we can calculate its corresponding y. Once we throw in an x and find its y, suddenly we have a point that's on that line. And remember, that line has an infinite number of points. We just need to find 2 of them. So I'm going to take you back to the notes so you can see exactly what's happening here. Okay. So going back to the notes, if we want to strategically choose any 2 values for x, our input, I would actually recommend starting off by saying, what if we made x equal to 0? And remember, I'm picking this value. I'm picking this value because it's going to make our lives so much easier. So I'm going to say, what happens if I let x be 0? Well, let's test it. I'm going to plug it into my equation, and I'm going to do my math. So 3/4 times 0 is 0, and 0 plus 3 is 3. So notice that I calculated the x value's corresponding y value. So this represents my first point on the line. X, then y. 0, 3. Now, we had the discussion that we need 2 points to make a line. 1 point is a point in space, but we need 2 points so that we can connect them to make a line. So, speaking strategically, we could just choose any random number and plug it in here for x, but I know that you guys like integers. I know that you like values that are not decimals because they're easier to graph. So what I would recommend is if you had to choose a number to plug it into here as a second number besides 0, you may want to pick a number that matches the denominator. So in this case, I'm going to choose 4. Let's let x equal 4. And I want to show you what this looks like when we do this. So if I let x equal 4, take a look at what happens. 3/4 times 4. Recall that this 4 is over a 1. If I write it over a 1, do you notice that the 4's are going to cancel? Numerator for denominator. Another way to think about this is 3 times 4 over 4 times 1, because this is over a 1. So it's 12 over 4, which is just 3. Regardless of which approach you take, you know that the 4's are going to cancel and it leaves you with just a 3 plus 3. So that was really nice. You chose the number that matches your denominator so that you can cancel the numerator for denominator. We're dividing out that common factor of 4 from both. And that leaves me with y is equal to 6. Notice that I plugged in a 4 for x and I tested it. I plugged it in and I said, okay, well, if I make x 4, what's y? We did the math and we found it. Y is 6. So my next point on this line is 4, 6. Okay? This all represents steps 2 and 3. We chose our x values. We chose 0 because that's the easiest. You should always choose a 0. It's just going to make life super easy. And then we chose the value here that matched the denominator because I had a fraction. If it's a whole number, then you could choose any value you want. You just have to make sure that it fits on your graph. Because remember, we're graphing these by hand. So we want to make sure that it fits on the graph. Okay? Once we chose our two x values, we calculated their corresponding y, input, output. And then we wrote down the ordered pairs. Once we have our two ordered pairs, all we have to do is plot the 2 points and connect with a straight line. Let's see this with a graph. So I'm going to turn the page and continue with you guys. Again, if you have any questions, don't hesitate to ask. Okay, let's try this up here. So we are going to graph by plotting points this first example, negative x minus 3y is equal to 6. According to the rules on the previous page, step number 1 is rewrite the equation in slope-intercept form. So step number 1 is get this equation in y equals mx plus b format. Okay, so in order to do that, we want y alone. Notice we have a negative x on the same side as that term with y. So we're going to move the negative x over. We do that by using the opposite operation. So now I have negative 3y is equal to, instead of writing 6 plus x, I want to write this in descending order. The term with the variable goes first. So it's going to be a positive x plus 6. Next, I want y completely by itself. Notice it's negative 3 times y. So if I want to get y alone, I need to divide by that negative 3. Now recall, we're going to do that to each term individually. Be careful with how you rewrite this. The negative 3's will cancel each other out, leaving you with y. A positive divided by a negative is a negative. And the coefficient of my x here, even though it's not written, is a 1. There's a 1 here. So that 1 is over 3. So we're going to write 1 over 3x. Notice that I've split it up so that it's a fraction, a coefficient, then the variable. The number in front of the letter. And then we have a positive 6 divided by negative 3. Well, that's just a minus 2. Okay? Hopefully, so far, so good. That's step number 1. Get y by itself, meaning rewrite the equation in slope-intercept form. Next, we want to strategically choose 2 values for x. So what I would recommend is letting x be 0 first. And then we'll pick the next value for x. And actually, while I am working through the value of y when x is 0, why don't you type into the live chat what number I should plug in for x besides 0. So go ahead and punch that in while I work through this first piece. So we are going to let x equal 0, because again, that's the easiest, right? It's going to zero out the term and it makes our lives really, really simple. So we have y is equal to negative 1/3 times 0 minus 2. Okay, all I did is make a substitution. 1/3 of 0 is 0, and 0 minus 2 is simply negative 2. Okay, excellent. And Brittany, nice job. You're exactly correct. That's perfect. So notice here that when I plugged in a 0, yes, Hyder, Nicole, that 6 will actually work as well. And Alyssa, the negative 3 will be beautiful as well. Okay, so and the 3, the 6, the negative 3, all of that will work. Excellent, guys. So my first ordered pair is going to be 0, negative 2. All right. So my input was 0, my output was a negative 2. If I go over to the graph, 0, negative 2, 0 on x, and then negative 2, 1, 2. There's my first point on this graph. But remember, I need 2 points to make a line. So you guys had suggested that I can make x a 3, or a negative 3, or a 6. Any of those values are going to be awesome. So for the sake of simplicity, I'm going to just say, let's make x equal to 3. I'm going to replace my x with 3, and I'm going to continue with the math here. Notice that the 3's will cancel. That leaves me with negative 1 minus 2. And negative 1 minus 2 is a negative 3. So now we're going to write the ordered pair that corresponds to this one. When x was 3, we found that y was a negative 3. So when x was 3, y was a negative 3. There is my second point. I'm going to go ahead and plot this point 3, negative 3. So we've got 1, 2, 3. Negative 3 is 1, 2, 3 here. Once you've plotted both points, please take a straight edge and connect them so that it's easy to see what this line looks like. I always like using a straight edge so that way you can see all the other points that correspond to that particular line. So I wanted to take a moment and show you something. I want to dissect this particular graph just a little bit more. Do you guys see that as I follow this line, that I have another perfect point right here? Do you see how the line goes through that point perfectly? And if we looked at this point right here, let's figure out what the ordered pair is. So this ordered pair is 1, 2, 3, 4, 5, 6. 6, comma, negative 1, negative 2, negative 3, negative 4. So this is 6, negative 4. This point is 6, negative 4. I want to see if this point is actually accurate. So what I'm going to do is, and this is just a test, so I'm going to write test here. I'm going to take my equation y is equal to negative 1/3 x minus 2, and this time I'm going to let x be 6. So negative 1/3 x is 6, minus 2. Notice that 3 goes into 6 twice, so it becomes a negative 2 minus 2, and guess what? Y is negative 4. So it works. We know that we've been doing the math correctly. Sometimes it's helpful to find a third point just to make sure that your line is looking good. Okay? Now, what I'd like you guys to do is to follow the steps super, super specifically. Okay? Don't overthink it. I want you to take a look at number 2 here. Number 2 says negative 5y is equal to 10x. I want you to follow each of the steps that you were just given, one by one by one, and then I would like you to graph that line. So let's see what you guys come up with for number 2. I'm going to give you 2 minutes to work through this, and I'm going to start that timer now. Okay, so let's see how you guys fared with this particular question. Okay, first step, get y by itself. I know there's only 2 terms here, so don't panic, don't freak out. We just want to get y alone. So if we think about it strategically, we know that y is attached to a negative 5 by multiplication. So what we're going to want to do is get rid of it. So we're going to start by dividing both sides by a negative 5. That's our first step. When we divide both sides by a negative 5, notice that that's going to give us y is equal to, and a 10 divided by negative 5 is a negative 2x. Okay, there we have y completely on its own. Believe it or not, this is still slope-intercept form. This is y equals mx plus b. That plus b doesn't exist, so it's actually plus 0. Keep that in mind. This is y equals mx plus b, and in this case it's plus 0 when you don't see that there. Okay, next we're going to pick 2 values for x. We get to choose. Like I said before, using 0 is a great call, so why not continue doing that? So we're going to make sure that we choose 0 for x, and we're going to plug that in. So we have y is equal to negative 2 times 0, and then we get that y is 0. So awesome. Our first ordered pair, our first point on this line, happens to be the origin, 0, 0. So I'm going to go ahead and plot that. Now for the next one, we can choose any value you want, any value we want. It's not a fraction anymore, so we don't have to pick a number that matches the denominator because the denominator is 1. So we can choose whatever we'd like. Now for the sake of fitting in this graph and just for the sake of being different, I'm going to choose negative 3 because I feel like it. You could have used any number you wanted to, any number your heart desires. So I'm going to plug in a negative 3 for x, and notice I have to do the math to figure out what y is, and that gives me a positive 6. So when x is a negative 3, we know that y is a positive 6. So I'm going to go ahead and plot that point. So negative 3, 1, 2, 3, 6, 1, 2, 3, 4, 5, 6. Perfect. Once we plot 2 points, we connect them with a straight line. That looks pretty good. And there you have it. There's your line. Okay. If you plugged in a 1, you should have had 1 comma negative 2. See, there it is. If you plugged in a 1, I bet you had 1 negative 2. If you plugged in a 2, I bet you had negative 4, right? That's the beauty of these lines, the fact that they have an infinite number of points. So as you're choosing x coordinates, you're going to do the math to find the corresponding y, and then go ahead and graph it. All right, let's turn the page to continue. Okay, next I want to talk about finding x and y intercepts. Okay, so if we take a look at these graphs up here, I want to talk about what it means to be an intercept. Think of like football, right? When there's an interception, isn't it where the player catches that ball, where the player and the ball meet? They catch it, right? That particular player catches it, so it's an interception. So when we think of the X-intercept, think of where the line hits the x-axis, okay? So specifically, if we're looking at our line here, this is my line, where does this line hit the x-axis? Well, it hits the x-axis here. So I would like you to put a point right there, okay? Would you guys type into the live chat, would you tell me what the ordered pair is for this particular x-intercept? And then would you also tell me the ordered pair for the y-intercept in this graph? So I'm going to write here that this is the x-intercept. Go ahead and type in the ordered pair for that. And then I'm also going to note that this point where the line hits the x-axis, where it meets the, or excuse me, where the line hits the y-axis right here, that represents the y-intercept. So I'm going to go ahead and label this y-intercept. Good, thank you, Brittany. So you're saying the x-intercept is at 1, 2, 3, 4, comma 0. I love it. Well, what about the y-intercept? Notice here that in order for the line to hit the x-axis, we figured out what the value is for x, and we know that the corresponding y value has to be 0. No worries, Alyssa. Take care of the family. It's good seeing you. So we have 4, comma 0. Next, we want to state the ordered pair for the y-intercept, and you guys are typing in there that it's 0, 2. I love it. Do you notice that with both intercepts that you have zeros? You have zeros in specific locations. So if you want an x-intercept, you'll figure out what the x value is, but you know that y has to be 0. Otherwise, you won't be on the x-axis. If, for instance, your ordered pair was 4, 1, you'll be in quadrant 1. If it were 4, negative 3, you'll be in quadrant 4. So if you want to be on the x-axis itself, that y has to be 0. Similarly, with the y-intercept, the x has to be 0. Because you start in the center, you don't move left or right, and you simply go up 2 units. So 0, 2. We're going to do the same thing for our second graph here. Notice that if I follow this line, I want to figure out where it hits the x-axis. So this line hits the x-axis here at that point. And that particular point has coordinates 2, 0. Similarly, take a look at the line and follow it as it hits the y-axis, and it hits the y-axis here. And that ordered pair is going to be 0. I believe that's a negative 8. Let's check it out. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So 0, negative 8. 2, 0 represents the x-intercept. 0, negative 8 represents the y-intercept. I wanted to illustrate the x and y-intercepts by actually having the visual here because I want you to see where it would be. I want you to kind of have that sense of, oh, that makes sense. There's only one place to have an x-intercept, and that's where the line hits the x-axis. Same thing with the y-intercept. When we have a visual in our minds, this concept of finding it algebraically becomes super, super, super straightforward. So let's read what it says here. To find the x-intercept, we are going to set y equal to 0 and then solve for the x coordinate. Remember, the x-intercept is written as x, comma, 0. That is super important. If you want one of the intercepts, you have to zero out the other. Okay, if ever you have two variables, if you want one of the intercepts, you just have to zero out the other one. Similarly, to find the y-intercept, you're going to set x equal to 0 and then solve for the y coordinate. So the y-intercept will always be written as 0, comma, y. These are really important pieces to remember. Okay, this is going to contribute to any application problems that we're going to see later on in this semester. All right, having said that, I want to show you what it looks like calculating the x and y intercepts algebraically. So let's take a look. So for our first one, it says graph by finding the intercepts, write each intercept as an ordered pair. This is really, really important. I want to have a quick conversation with you guys. think about what it was like playing Battleship. I'm sure some of you have played Battleship. If you haven't, please get the game and play it. I mean, why the hell not? Especially now when we're stuck at home. Board games galore. So if you think about Battleship and you think about having the grid here and you have your ships that you've lined up and you're starting to guess where the opponent's ships are, and you're gonna yell out a command, essentially. You're gonna yell out a spot, right? So an example of a command you might yell out when playing Battleship is something like, G2, okay? The reason we say G2 is because on this particular grid, we have all of the letters at the top referring to each of the columns, and then we have the numbers on the side referring to each of the rows. So when I call out a command like G2, you know that you're going to go over to G, and you're going to go column G and row 2, and you're going to put a point there, right? And you're going to hope that maybe that blows up part of your opponent's ship, okay? So with Battleship, if you think about that and you think back to what it was like when you played as a kid or even as an adult, I mean, I still have it. I played like a couple weeks ago. So if you think about calling out G2, you have a specific location in mind. Now imagine for a moment that you and I are playing Battleship and I'm like, G. You're going to look at me and be like, you're not getting the point of this Battleship game, are you? Right? You're going to be like, you're calling out G, but that doesn't even make sense. Where? G where? Like, give me a number. So by shouting out one coordinate and not its pair, I have no idea what I'm actually referring to. So it's very, very, very important that every time you identify a point on a grid, you have to specify two coordinates, the column and the row in Battleship, or the X coordinate and the Y coordinate. Okay, it's very important that they come as a pair. Think about that. Let's go back to the notes. So we want to graph by finding the intercepts. Okay, no big deal. So I'm going to start by finding the X-intercept. So I'm going to write that the X-intercept has the ordered pair, some number, we don't know what it is, so I leave it blank, some number, comma, 0. And what this implies is that X is unknown, but Y, we know it. We want Y to be 0. So guess what? You're going to take this 0 and plug it right in for Y. You're going to throw it right in there. So let's take a look at what this looks like. Negative 2x plus 6 times 0 is equal to 12. Notice all I did was make a substitution. Notice in the directions here that tell us how to find the X-intercept and how to find the Y-intercept, nowhere does it say you have to rewrite it in slope-intercept form. Nowhere does it say that. So by having my equation in standard form, remember your variables are on one side, your constant is on the other. By having the equation in standard form, I actually like it a little bit more. It ends up being really, really easy to solve. So I'm going to go ahead and solve this. We have negative 2x plus 0 is equal to 12. And we know negative 2x plus 0 is simply negative 2x. And then I divide both sides by negative 2. And I find that x is negative 6. So the cool thing is you can take this negative 6 and plug it right in here for my x-intercept. So I'm going to put on the side here that my x-intercept is negative 6, 0. So let's plot that point first. Negative 6, 0. Start in the center, go left 6 units. 1, 2, 3, 4, 5, 6. Sorry, the grid is so tiny. No big deal. It serves its purpose. So we've got negative 6, 0. And now we simply have to find the y-intercept. Recall that with the y-intercept, you want to zero out x. So that's what it looks like. The y-intercept has an x-coordinate of 0. We know what that value is. And a y that, I don't know, we have to figure it out. Let's do the math. So we have a negative 2x, but x is 0, plus 6y is equal to 12. Okay, negative 2 times 0 is simply 0, so 0 plus 6y is equal to 12. 0 plus 6y is just 6y. And then we want to divide by 6. And we get that y is 2. So my y-intercept is going to be 0, 2. Notice with the x-intercept, it's on the x-axis. Success. That is success. Your x-intercept should be on the x-axis. Your y-intercept, 0, 2, 0, 1, 2, is on the y-axis. So again, consider that success. It should be on the y-axis. Connect the two lines, or the two dots with a line. And voila. We just graphed the equation negative 2x plus 6y is equal to 12. It's as straightforward as that. Okay? Let's do another one together because I want to make sure that we're all on the same page, but I'm hoping that you guys are like, okay, this is not a big deal. This is not bad. First things first, let's write down x-intercept. And I want you to write the format. I think the more you write this down, the easier it's going to get for you. Okay? X-intercept is some number. I don't know what it is. I'll figure that out in a second, but we know that y has to be 0. Similarly, for the y-intercept, we want x to be 0. And we'll figure out what y is. Okay, let's do the math. So we're going to plug in a 0 for y. Okay, so I have 0 is equal to negative 1/5 x plus 1. So our goal here is to solve for x. It's the only variable we see, so it's the only thing that makes sense. So if I want to solve for x, I could move the 1 over to the 0 by using the opposite operation, or I could move the negative 1/5 x over to the 0 by using the opposite operation. To make things a little bit, I guess, familiar to you guys, what I'm actually going to do is I am going to subtract the 1. Because this is what's familiar to you guys from what we've done in class. So I subtract the 1, so it goes away here. And we have 0 minus 1 is negative 1 is equal to negative 1/5 x. We learned that if we wanted to cancel fractions in an equation, we have to multiply every term by the LCD, by the denominator. In this case, I'm going to multiply each term by 5. Okay? Notice that when I multiply each side by 5, 5 times a negative 1 is negative 5. And 5 times a negative 1 over 5 means that these cancel, and it leaves me with negative 1x. And now I'm one step away from having my value. Divide both sides by negative 1, and voila, x is equal to 5. So my x-intercept is 5, 0. Okay, we're going to go ahead and plot 5, 0. 1, 2, 3, 4, 5. There's my 5, 0. I'm going to do the same thing with my y-intercept, except this time, obviously, I'll make x 0. So we have y is equal to negative 1/5 times 0 plus 1. And this is just nice, because 1/5 of 0 is 0. So 0 plus 1 is just 1. So my y-intercept is 0, 1. Plot that point, connect it with a straight edge. I'm hoping that you guys have your straight edges at home as well. It's just going to look a lot neater if you use it. And voila, we're done. Okay. Let's turn the page. And I would like you to try number 3. So I'm going to show you what number 3 looks like. Actually, why don't you skip number 3 for a moment? We'll come back to that together because that's a little bit tricky. What I'd like you to do is do number 4. So right now, go ahead and do problem number 4 by finding the x and the y-intercepts and then plotting those 2 points and then connecting them with a line. Again, I'm going to give you 2 minutes to do this. Okay, so let's take a look at how you guys fared with problem number 4. Okay, so I see that some answers are coming in for the x-intercept, and I haven't seen a y-intercept yet, but that is totally okay. So just continue to throw those into the live chat. I love it. I'm loving what I'm seeing right now. So we're going to go ahead and find the x-intercept first, just like you guys did. So notice with the x-intercept, we want y to be 0. So I'm going to plug that in here. So we have -3 times 0 is equal to 4x plus 6. Excellent. Thank you, Brittany. So we are going to do the math. 0 is equal to 4x plus 6. At this point, I'm going to bring the 6 over so that way the 4x is by itself. Thank you, Erica, Hyder, everyone. This is fantastic. And Tiara, very nice. We're going to subtract the 6 from both sides. So I have -6 is equal to 4x, and then I divide by 4. Now, the really cool thing about writing it this way is the first thing we notice is that 6 over 4 reduces to 3 over 2, right? And we also learned from our second page, when we want to graph a fraction like this, it's usually helpful to rewrite it as a decimal. So in this case, we're going to say that the x-intercept is -1.5, comma 0. So everyone who typed in -1.5, comma 0, beautiful job. That is perfect. Okay, that's excellent. Hi, Hyder. So we're going to plot the point -1.50, so -1.5, 0. So it's right here in between those two grid marks. Next, we're going to do the same thing with the y-intercept. We want x to be 0, and we need to figure out what y is. Aha, I've got some values coming in. Very nice. So your guesses are 0, -2. Let's do the work. So we have -3y is equal to 4 times 0 plus 6. Notice, and I'm sorry that my ink is bleeding onto other parts of the page. So this goes away because 4 times 0 is 0. 0 plus 6 is simply 6. I hope you guys are okay with me simply writing it this way and simplifying. I'm going to divide both sides by -3, and you are correct. For everyone who said that the y-intercept is 0, -2, beautiful job. So 0, -2, 1, 2 is right here. Take your straight edge and connect it. I'm trying to make this as neat as I can. Beautiful. If you think that you do not have a straight edge, you are wrong. Anything can be a straight edge. Your ID, a credit card, the edge of a folder, the edge of a cell phone, right? Any of those things will serve as a great straight edge. So you should get into the habit of doing that. It just makes things a lot easier to see, okay? Now, I want to take a moment and go back to number 3 because this one's interesting. And I think if you start this, you'll notice right away why this particular problem is interesting. So let's take a look at number 3. So we're going to start off by saying, okay, x-intercept, we know that y has to be 0. So I'm going to plug in a 0 for y. Okay, I'm going to do the math. We know that 4 times 0 is 0, and 0 minus 8x is just -8x, or -8x. I'm going to divide both sides by -8, and I get a 0. So my x-intercept is 0, 0, which, guess what? If my x-intercept is 0, 0, so is my y-intercept. It has to be, because the line is going through the origin. So this is both the x-intercept and the y-intercept. That's what that is. Both of the intercepts happen to be 0, 0, the origin. But as we learned from the previous page, we don't know where this line is. Does it go like this? Does it go like that? Is it a little bit more steep and slope? Like, how do we figure this out? We have to go back to our toolbox. Recall, I'm going to show you something. I'm going to flip back. Recall that we learned about Graphing by plotting points. We learned this whole idea. So if we need to find another point on a graph, well, let's use these rules. Let's use graphing by plotting points. Anthony, that's a great question. If when you do the math and you find that one of the intercepts is the origin, then yes, they will both be the origin. It has to be, right? It has to, because both coordinates are 0. So yes. Let's go to the original equation, and we are going to rewrite this in slope-intercept form because that was the first step to graphing by plotting points. To rewrite this in slope-intercept form, I'm going to bring over the 8x, because remember, we want y by itself. So we have 4y is equal to 8x plus 0. I'm just going to write 8x. Next, I want to get y by itself, so I'm going to divide by 4. And we get that y is equal to 2x. Now that we have our equation written in slope-intercept form, I can pick a value for x. How about we pick, I don't know, it doesn't even matter. Let's make it a 2. So I'm going to let x equal 2, which means y is equal to 2 times 2, which means y is equal to 4. So on this graph, my next point, so that I can actually see what the line looks like, my next point is 2, 4. So let's graph that. 2, 1, 2, 3, 4, 2, 4. Once you've plotted the second point, we can now connect them with a straight edge and draw our line. And there you have it. But I want to stop there because that's a lot of information. So you guys have an assignment. You have several assignments in Unit 4 in your Lumen. At this point, you can do the assignment that says X and Y intercepts. You could even do the assignment that refers to graphing by plotting points or plotting points. So go ahead and take a look at all of the practice assignments that are in Unit 4 and select the ones that you feel we've learned so far. Always look for the assignments that correspond to what it is that we cover in class, okay? I won't set a due date yet because we still have to cover Unit 5 before we have our next test. So we do have kind of a lot of time before that actually happens. But I wouldn't wait, please. Your grades depend on it. You need to have a B- or better in order to move to the next course. So you want to make sure that you're on top of this. You want to make sure that you're practicing all the material so that you can master it and you can be successful in the next class. So it's very, very important that you accomplish all of these things. Remember, in the Lumen, that's a practice, right? That's your homework. That's for practice. And you can continue to do it until you get the 80% or higher that you need, right? You can just click similar exercise and keep doing it until you've mastered it. I urge you to do that. Don't let those points go away. So with your chapter 3, that's pretty much done. We already took a test on chapter 3, so we don't have to worry about those assignments anymore. Those are past due. So just focus all your energy on Unit 4. I wouldn't start Unit 5. If you want to get ahead, that's totally cool, but I would wait on that because that one is a little bit tricky. So just focus your energies on Unit 4 and make sure that you're working through there. Again, I won't put a due date for a little while because I want to see how we move through the notes. There's no set date for the test yet, okay? Let's see, so when both intercepts are 0, you have to plug in a different number for x to find a point. Yes, Brittany, you are totally right. When we had the case where we had both intercepts as 0, we still need one more point to make the line. So we have the freedom to choose an x value and calculate its corresponding y. And then bam, we have 2 ordered pairs. Christina brought up a really good point, and Nicole as well. The Unit 4 practice assignments, for whatever reason, are on the bottom of the practice homework list. So if you go into your grade book and you see all of the practice assignments, Unit 4 is going to be at the very bottom. I have no idea why it's down there. It's some sort of coding thing, not really sure. But just scroll all the way down and you'll see the set that corresponds to Unit 4. Anthony, you asked a great question. If you ever need any extra help, first off, email me, okay? You have my tutoring hours, but I'm obviously going to be home and I'm available for many, many, many hours outside of those tutoring hours. So email me no matter what. Let me know if there's a specific time you'd like to meet. We'll coordinate, we'll find a block, and then we will meet via Zoom. We're not going to meet in the YouTube live stream because it doesn't make sense. So if we're going to have a tutoring session, all you have to do is email me and we'll meet in Zoom. And we've already practiced Zoom, so you know what that looks like, okay? But you have to email me. We have to plan to meet. Otherwise, how do we know, right? I don't see anything else coming in, which is awesome. If you do have questions, email me. I check my email all day long now because I'm literally home and I'm kind of bored. No, I'm just kidding. I'm not bored. I have a lot on my plate, but I'm still okay with it. So please shoot me an email. All right, guys? Well, this was fun. I hope you enjoyed the class. We will pick up where we left off next time, and that is going to be Thursday at 2 o'clock. So make sure you log in a little bit before. I'll try to start the live stream a little bit earlier than a couple minutes just so that you're ready, but just be online. Expect the YouTube live stream to start at 2 o'clock. All right, guys?